lesson, we're going to take a look at some more material out of Unit 7-8, where we're working with linear relationships. And what we're going to look specifically at is some stuff from Box C here, where you need to draw a scatter plot by making a table of values and then plotting those ordered pairs onto the graph. And for some stuff from Box D, we're going to look at what is meant by interpolation and extrapolation. These are ways of getting additional values from your graph that don't appear in your table. So we've got a situation that we're given here. A carnival charges $10 admission plus $5 for each ride you go on. The total cost, which we're going to represent by C, is given by the equation C equals 5R plus 10, where R is the number of rides. So again, that's $5 for each ride, so 5 times the number of rides, plus this $10 admission that you have to pay just to get into the park. So we want to graph this thing, but before we can graph it, we want to fill in this table of values. So we've set up this table. We've got number of rides, 0, 2, 4, 6, 8, 10, and we want to find the total cost for this number of rides. And to do this, we're just going to sub our values of R from this first column into our equation for C. So our equation is 5 times R plus 10. And I've left those little brackets there, and we're just going to take our value of R, which is 0, and substitute it in. 5 times 0 is 0, plus 10 is just 10. So our total cost to go on 0 rides is $10. And this makes sense, because we have to pay that $10 to get into the park, even if we don't go on any rides. Now, to get the coordinates of the point that we want to plot, this is our ordered pair xy. So our first number always comes from our first column, 0. Our second number here always comes from the second column. So our point is going to be 0, 10. And we can repeat this to fill in the rest of our table here. So if we go on 2 rides, it's going to be 5 times 2 plus $10. 5 times 2 is 10, plus another 10 is 20. So from the first column, we have a 2. From the second column, we have a 20. And keep in mind that these points that we have in this third column are, the first number represents R, the number of rides, and our second number represents C, the cost. So we can keep going here. We've got 5 times 4 plus 10. 5 times 4 is 20, plus another 10 is 30. So we'll have the point 430. 5 times 6 plus 10. 5 times 6 is 30, plus another 10 is 40. So we'll have the point 640. And by now you should be starting to see a trend. Our number of rides is going up by 2 every time, and our values of cost are going 10, 20, 30, 40. They're going up by 10 each time. So we can probably just sort of not write out the formula entirely and fill in the rest of this table here. So it'll go 10, 20, 30, 40, 50, 60. So our points here will be 850 and 1060. Now we want to set up our graph. So this grid that you have here is exactly the same as the grids that you have in the learning guide. We have 20 boxes along our horizontal axis, and we have 20 boxes going up on our vertical axis. And the first thing we want to do is we want to decide what we're going to plot on our horizontal axis, our x-axis, and what's going to go on our vertical axis. And the way you decide that is based on how your chart is set up. If our first column here is number of rides is going to go on our x-axis. So we'll put number of rides down here. And that means cost has to go up the side here. So I'm going to put my label right up here at the top. Cost in dollars. Now I need to lay out my graph here. And what I want to remember is that I want to put a scale on both of my axes here that has to go up by the same amount every time. So I've got, my table goes from 0 to 10, and I want to have a little bit of extra space on my graph. So I don't want my graph to just go up to 10. I want to be able to have extra points on it. So what will be convenient here is if I have each of these boxes represent 1. So this will be 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. Now, if I look at my total cost, it goes from 10 up to 60. Of course, I always start at 0, 0, right down here at this bottom corner. And I want my cost to go at least up to 60, but I want to have a little bit of extra space as well. So what will work nicely here is if I go up, each box represents 5. So 2 boxes will be 10, so we'll go 10, 20, 30, 40, 50, 60, 70, 80, 90, and that puts 100 right there at the top. So on my x-axis, each box was represented 1, and on my vertical axis, each box represented 5. So usually when you're going up, you go up by 2s, by 5s, sometimes by 1s, sometimes by 10s, something like that. And then we just want to graph these points. So our first point here is 0, 10, so 0, 10 is going to be right here. 220 is going to be right here. 430 is going to be right here. And 640 is up here. 850 right here. And 1060, let's see, go over 10, up 60. Okay. And if we read down here at the bottom, it says we can draw a straight line through the points. Now what that means is these points that I've plotted here all form a very nice straight line. So if you take your ruler, I take my ruler too, what we can do is we can draw a nice smooth line right through there like this. So because we can draw a straight line through the points, what we can say is this relationship is what we call a linear relationship. Linear just means that the points, the trend followed by the points, or the pattern formed by the points, is a straight line. So now we're asked a couple of questions here. We're going to use this graph to find some values that don't appear in our table. So the first thing it asks us to do is use interpolation. And what we want to use interpolation to do is find the cost if you go on 5 rides. Now this is pretty easy here. If we're given a number of rides, we want to find that number on on one of our axes here. So if it's a number of rides, we have to look down here on our x-axis, because that's where we've plotted number of rides, and we want the number 5. So 5 would be right in here. And if what they're asking us for is the cost, we want to start at 5 right here, and then we want to go up until we get to this line that we've drawn here. And then from this line, we want to go across to our other axis, where we've got the cost. And we want to read off the number that we have there. The number that's there is halfway between 30 and 40, so that's going to be 35. So the cost is going to be $35 for 5 rides. And we can also do this the other way. The next one asks us to find the number of rides if you have $45. So $45 here represents the cost right here. So we find that on our cost axis, and then we go across to our line, and then we go down. And we read off the number that we have. Well, we're halfway between 6 and 7, so that would be 7. Sorry, we're halfway between 6 and 8, so the number would be 7, so we would be able to go on 7 rides. Okay? So the first one, we were going from the x-axis up to the line and across. The second one, we were going from the y-axis to the line and then down. But you always want to go over to that line that you've drawn every time. Now, why is this called interpolation? If you notice, the points that we got to on our line after we went up or we went across are here and here. And we've got these red points that we plotted from our table on either side of those points. So this is interpolation because we are working sort of inside the points. Next, we're going to use a process called extrapolation. Now, extrapolation is when you are working sort of beyond the points that you've plotted from your table. So you sort of have to extend your line. So let's say extend line. So when I drew my line of best fit, you'll see that I drew it so that it went all the way to the end of the graph. Okay? And I need to do that if I'm going to use extrapolation. But the same process is going to apply. We want to find the cost if you go on 15 rides. Well, 15 rides, that's a number of rides. So we find this down on our number of rides axis here. That's right here. And then we want to go up to our line that we've drawn. So I got to scroll this up a little bit more. Up, 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 up. And then we want to go across to our cost axis, and we want to read off the cost. Our cost is going to be 85, so that would be $85. Similarly, we want to find the number of rides you can go on if you have $95. So we'll find $95 on the cost axis, go across to our line of best fit here, and then we'll go down. And we'll see that. We just read off what that is. Well, that'll be 17. So we would be able to go on 17 rides. Scroll down there. Now, there's another way we can answer questions like this. If you look at the back of the page, we've got the same situation again. $10 admission plus $5 for each ride you go on. We've got the total cost given to us by this equation. We can use the equation to find costs or number of rides. And the key word you'll see in a lot of problems is they'll ask you to do this algebraically. If you see that word algebraically in the question, they want you to use the equation. So let's use the equation here to find the cost if you go on 25 rides. We'll start by just writing out our equation. C equals 5r plus 10. And then let's look at what they give us in the question. They give us 25 rides. 25 rides is a value of r. R equals 25. So let's sub this into our equation. So we replace r with 25. And then we want to solve or evaluate for the other variable. So we do the multiplication first. 5 times 25 is 125 plus 10. And then 125 plus 10 is 135. So the cost is going to be $135. Let's take a look at the next one here. Use the equation to find the number of rides you can go on if you have $510. Well, again, let's write out our equation here. C equals 5r plus 10. And again, they give us a number here, 510. Now, is this a number of rides or is it a cost? Well, it's money, so this is telling us that this is our total cost, 510. So let's sub that into our equation. For C, 510 plus 5r plus 10. Now we need to solve this equation for r. So let's start by subtracting 10 from both sides to get the r all by itself. So I'm going to subtract 10 over here, subtract 10 over here, and that's going to give us 500 equals 5r. And then to get the r all by itself, I want to divide both sides by 5. We get r equals 100. So this is telling us that if you had $510, you could go on 100 rides. So you can do these things graphically, or you can do them algebraically.